Hi, I'm going to go through the density with volume exercise 1b. Density with volumes. It was exercise 1b from last lesson. You'll recognise the questions because you'll have had a go at them, or you'll have at least had time to look at them. I'm going to go through these four. I'm going to put my just written work solutions as a PDF on the Show My Homework as well, but I do advise you to just spend the 7-8 minutes it's going to take me to do these four questions, or at least watch the first two, I would recommend, because you're going to get a much better understanding from listening to me explain through it rather than just seeing some maths on a piece of paper, because trust me, it'll take longer for you to understand it through looking at my working on paper than sitting here and just listening this out and making some notes if you need to. I'll explain some more at the end, and I'll put some more stuff on on the actual Show My Homework task as well, just so I'm not talking too long at the beginning. I'm going to do them in a weird order because I genuinely think question 3 and 4 were easier than question 1 and 2. It was a bad order by me on the questions, and I'll take the heat for that. But we're going to do question 3, then 4, then 2, then 2 again. I'll screen cap 1, or I'll just write up the information for 1 on there. Okay, so starting with question 3. This is a nice sort of common looking question. You can see these are all questions from exams as well. Question 16. So if you're doing this well, you're doing well. These are obviously before the 2017 change, so these might be a little bit earlier in the paper now. The first idea is they give you so much information in these questions, and you just need to realise, well, what is a load of rubbish that I don't care about? Yeah, it's made from metal, but that's not really going to change anything I'm doing. It's got a cross-section. I mean, they've drawn it for us, so why have they told us the dimensions? I can see the dimensions drawn for me here. I don't need any of that part. Literally, all I need is the density is 5. We want to calculate the mass, and I'm going to go find the volume now from this diagram. Once I find the volume, it's just like them beginning questions we were doing where you just draw your triangle and you see what calculation you need to do. So let's find the volume of this. We need to find the volume of the front face. Area of a trapezium is one they like to chuck in because it's a bit harder than just an area of a triangle or a rectangle. So they like to chuck these in with these questions, and this is a formula you need to know, or at least know how to do it. So kind of the actual formula for it is this. And what that means is, don't some people have a little rhyme? Add the length of the find the average of length of the parallel sides and times it by the distance between. That basically means take this, add that, divide it by 2, which finds the average, and then times it by the height. So in the case of my actual question, well, the area of the trapezium is going to be 8 plus 12 divided by 2 times by the height, which is 6. So this is actually just going to be the area of the front face. Do it in 2 steps. 8 plus 12 is 20, divided by 2 is 10, so that's 60. And then to find the volume, I need to times it by the depth, or the length, or the height, depending on how the shape is kind of shown to you, but in this case it'll be the depth. So I need to do 60 times by 20. That gets me to 1,200 centimeters cubed. So my volume is 1,200. Let's draw out my little triangle. Density equals to mass over volume. We want to find the mass. So let's do density times volume. Remember, this line means times, that line would mean divide. So the mass equals to 5 times 1,200. The mass equals to 6,000. Let's think of our correct units. Give your answer in kilograms. This is 6,000 grams because we've used, this is grams per centimeters cubed, and we've used this as centimeters cubed. So we keep the unit that's there, grams. The answer in kilograms would then be 6 kilograms. So this is a correct answer here, but that is what they've wanted, and maybe that would get you your 4th mark in a 4-mark question or something like that. Okay, this one here. Solid cylinder, again, they've drawn this on there for us. We don't need any of that. It's already shown on the diagram. We don't care that it's made of wood particularly. We care that the density is 0.6. So once I write that out, I can cross that off. I've used that information. They want us to find the mass. So basically, kind of the same stuff as last time. Volume I'm going to go find. Volume of a cylinder. Again, we find the area of this front face, and then we're going to times it by the height this time, or the depth, whichever perspective you look at it from. So the area of the face, which is this, well, that's just a circle, isn't it? So it's pi r squared. The radius is 4, so it's 16 pi. I've done 4 squared there to get 16. And I'm going to leave it like this because we know how to work in terms of pi. You're really good at that, and it makes your working out so much easier later, rather than having really horrible decimals. So then the volume, we want to do that, 16 pi, times by the height, which is 10. We can just write that as 160 pi for now. So I'm actually going to write 160 pi there, and I'm also just going to write that that equals to 502.6548. We want to find the mass. Well, we can draw a triangle out. We know from the last question that it's going to be density times volume. If we cover that up. So the density is 0.6. The volume is, we can use either of these. I'm just going to use my number version. It's probably easier to type 160 pi in your calculator though. And then when we do that, we're going to get 301.5928 ... It wants it to 3 significant figures. So 1, 2, 3, draw a line here. That 5's going to tell me to round up. So it's 302. Again, take a note of your units. Grams per centimetres cubed, so this mass is going to be in grams. And that's our final answer. Going back to question 2, these were a little bit harder because you had to find some density. Finding the volume wasn't as hard because it was just a cuboid, but you had to do some stuff at the end kind of justifying an answer, so this is why I think it was a little bit harder. So again, we've been drawn that, so we're not too fussed. The mass of the wood, the mass is 8 kilograms. Keep your units there because you might have to convert them, and I'm actually just going to write that that is 8,000 grams, just in case I need to work in grams. It will float if the density of the wood is less than the density of the seawater, so we're also going to have to find density of the seawater. In a pool, 1 litre of seawater, so the volume is going to be 1 litre. We'll get back to that in a second, and it has a mass of 1,030 grams. And then let's go density, we want to find that. Volume and density, we want to find that. This little note down here, so I've used that piece of information. 1 litre, it says 1 litre is 1,000 centimetres cubed. So actually that is a genuine conversion. They've not just made that up for the question. That is something you might be expected to know at some stage. So it's worth remembering. They won't always give you the note. We're not going to use the litre value because we don't do calculations with litres. We do calculations with volume units, centimetres cubed, metres cubed, stuff like that. So that's why it's important we've converted that. Let's just go ahead and calculate the density of this, because we've got 2 values and we're finding a third. So we know density equals to mass over volume. So the density of the water is going to be the mass divided by the volume. So 1,000 times 1,030 that is going to get me 1.03. Put a little circle around that. We're going to have to check if that's a larger value or the smaller value of our piece of wood. Thing they've tried to trick you with here, 1.2 meters, that's 120 centimeters. You need to make sure your units are constantly consistent, otherwise your calculations just don't work. So the volume of this, we do 3 times 20, and then we times it by the length. I've done the same stuff as what I did for the last two. I found the area of this, that's 3 times 20, and then I times it by that. So 3 times 20 would be 60, times by 120 would be 7,200 centimeters cubed. So I'm going to write that there. So the density of this is going to be mass over volume. The mass is 8,000, the volume is 7,200. And this is 1.1 recurring, so 1.11111111. It says in the question the piece of wood will float in the seawater if the density is less than the density of the water. Well, 1.1 is larger than 1.03. Therefore, the wood will sink because the density is greater, so it will sink. Okay, and you'd need that line at the end to get your final thing. Justify your answer. Justify your answer means do all the working out. And then a final question, which I seem to have copy and pasted the same question. I will delete that and just write out the information because I don't have the other question loaded in my computer at the moment. Basically, we were told we had a shape like this, and we were told that was 2. This was 12. This was 15. This was all in centimeters. Just trying to remember what the question was telling me. I think that was all the information we needed from that. Yep. And then it told us in the question that the density was 8 grams per centimeters cubed, and it wanted us to find the mass. It also wanted to do something a little bit else at the end, but I'll explain that once we've done it. It wanted us to say, well, it said a shopping trolley. It can hold 250 kilograms. So how many of these bars could it hold? How many of these bars up here could it hold? So we had to find the mass to then see how many could fit into our trolley. So let's go ahead and find the volume. It also said it had a length, so it was going to look a little bit like this. I gave a hint on the sheet that it was going to look something like this. It had a length of 120 centimeters. So I'm going to find the area of this front face first. Then I'm going to times it by 120 to find the volume. I keep saying front face, but the fancy word is cross section. I think front face is also mathematical, and it makes a bit more sense to me. I'm going to split this up into 2 rectangles like this, and I'm going to get a third colour for this. So I'm going to split it up into shapes like that. So I know it's a length of 2 at the top there, and a height of 15. So the area of this is 30. That's exactly the same, 2 by 15. So that's also an area of 30. Just got to figure out this middle section here. Well, if this is all 12, and these are 2 up there, this is going to be 8, this length, because 2 plus 8 is 10, plus another 2 is 12. And this height, if the whole height is 15, I'm trying to think, did they give us another piece of information on the question? Sorry about this. I feel like they gave us that this inside was 13, because I've got that drawn on my diagram for the work solutions. So I think that's got a height of 2. That's the calculation I did anyway. So this would be 8 times 2, which is 16. So it would be 30 plus 30 plus 16. You can obviously pull the question up and see it, but I know this is ruining the impact of it a little bit. My apologies. So that is 76 centimeters squared, and then to find the volume we need to do 76 times 120, which will be 9120. So let me put that up there. So let's go ahead and find the mass. Density equals to mass over volume. So mass equals to density times volume, so it equals to 8 times 9120. When we go ahead and do that, we're going to get 72,960 grams. What we're checking is in kilograms, so I'm going to convert this into kilograms. And to do that, we divide by 1,000, because there's 1,000 grams in a kilogram. So it's going to be 72.6 kilograms. We need to check how many. So how many bars, which are 72.96 kilograms, go into 250 kilograms. The way I do this is I take the value I'm checking and I divide it by the weight of it. That is going to give me 3.4265. So that means I can fit 3.4265 bars in here. But the question's asking, well, how many full ones can I fit? That is going to be 3 bars. Another way you can do it is you can just count up in your 72.96s on your calculator, or count up in your 73s in your head. It's roughly the same. And you'll see that you can only get 3 of them in there before you go over. Okay, so there's going to be 2 tasks up for you if you've stayed this long, and I'll write this on summer homework as well because I don't expect many of you here. One task is about volumes, because you need volumes to be able to do these questions, and then one task is questions like this. But thank you for watching this if you did.